Now we're going to find the slope or the constant rate of change from a graph using something called the slope formula. Now the slope formula works for a graph, a coordinate point, or a table. And I'm going to show you all three of those in this video. Okay, so this is the second way that we can find slope. The first way is rise over run. The second way is the slope formula. And remember, I talked about in class that this slope formula is not going away. You're going to continue to see this in all of your math classes. So again, we're going to pick two clear points on our graph. Again, the clear points are any points on the line that also cover over or hover over a intersection point in the grid lines. If you're not sure what I mean by that, call your teacher over to review that with you, okay? So we're gonna pick two clear points. I'm gonna choose this one and this one. However, slope, you can choose any points. It doesn't matter if they're 2 points that are right next to each other. You may decide to choose this point and this point. That's a-okay. All right, now we're going to find the change in y over the change in x. This means that we're going to find the difference between the two y variables, y2 and y1, and the two x variables, x2 and x1. So in order to label that, I need to label these points as x and y. So I'm going to pick the point to the right just because it's the greater point. And I'm going to label this y2 and this x2. So 6 represents y2, 4 represents x2. And I'm going to label 3 y1 and 2 x1. Okay? Now it's very important that the x1 and y1 are next to each other and the x2 and y2 are next to each other. You cannot intermix those two variables. Okay, now I'm going to use the numbers and plug the numbers that I just labeled into this formula. So y2 is 6 minus y1, which is 3, x2, which is 4, minus x1, which is 2. Now 6 minus 3 is 3, 4 minus 2 is 2. And remember that in slope, it's okay to leave it as an improper fraction because when you get to story problems, it's actually easier to describe what that slope means using the improper fraction. So that's how to use the slope formula in a graph. Now we're going to talk about how to use the slope formula in a coordinate point, which is between 2 points that are on a graph, but we don't have the graph in front of us to look at. So again, we're going to use that slope formula of y2 minus y1 over x2 minus x1. We're going to label our points. So I know that 2 and 7 are my y variables. So I'm going to label the larger one as y2 and y1. And then 1 and 3 are my x variables. The larger one's going to be x2. Or I'm sorry, actually, the one that's next to y2 is going to be x2. And then the one that's next to y1 is going to be x1. Now all I'm going to do is plug my points into my formula. So I'm going to take y2, which is 7, minus y1, which is 2, over x2, which is 3, minus x1, which is 1. And I'm just going to solve this. 7 minus 2 is 5. 3 minus 1 is 2. Therefore, my slope is 5 over 2. All right, now we're going to go over one more, and it's how to find or how to use the slope formula in a table. So let's look here. Now, you can actually use this formula in a vertical table or a horizontal table. I'm going to show you the horizontal table, but it's the same process in your vertical table. Okay, so the table below shows the number of miles a plane traveled while in flight. We're going to use the information to find the approximate constant rate of change in miles per minute. So we have a table showcasing our time in minutes going up by 30, 60, 90, 120. And the distance in miles going up by 290, 580, 870, 1,160. So the first thing that I like to do is I like to label my X variables and my Y variables. Okay? Now for tables, I'm going to use that slope formula again. And if you forgot the slope formula, whoops, I messed up. The slope formula is y2 minus y1 over x2 minus x1, okay? Now, in order to do this, we're gonna follow the same steps that we followed here. We're gonna pick 2 clear points, and then we're gonna plug those points into the slope formula. So, I may decide to use this point in this point, okay? For the purpose of this class, it does not matter which points you choose. You might choose the first and second points, or the second and third points, or the third and fourth points. You might choose the first and the fourth point. It does not matter, okay? Now the next thing that I like to do is I like to label my y2 and y1. So I like to look at the y's, which are gonna be on the bottom, and I'm gonna... All right, sorry about that, I lost connection. So we're gonna finish, we're gonna label the larger y value, y2, and the smaller one, y1. Now, we've got corresponding x values for that y value. So if I was to write this point as a coordinate point, it would look like this, 60, 580, okay? Or 120, 1,160. So I'm going to label the x coordinate that corresponds with that y coordinate. So since this is y2, this is going to be x2. Since this is y1, this is going to be x1. Okay? Now all we're going to do is plug in these numbers into my slope formula. So I'm going to take y2, which is 1,160, minus y1, which is 5,080. I'm going to put that over x2, which is 120, and I'm going to subtract x1, which is 60. Now I'm going to go ahead and do some subtraction. 1,160 minus 580 ends up being 580. And 120 minus 60 equals 60. Now, by looking at these, I know right away that I can go ahead and simplify these. So if you can simplify slope, you always, always, always want to simplify. So I can actually divide both of these by 10. Okay, which would put me at 58 over 6. And then I can continue dividing these by 2. Which would put me at 29 over 3, okay? And that leaves me with my slope. Now, what would happen if I was asked to explain what this slope meant? Well, my 29 represents my y. Remember that? Because this is my change in y on top. So that represents my distance. And my 3 represents my x, okay? That represents my change in x's. So if I was to write this out, I would say that this plane traveled at 29 miles, because mile. So once I get that slope of 29 over 3, I can label this as the plane traveled at 29 miles per 3 minutes, because 3 represents my change in x, which x is our time in minutes, per 3 minutes. So if I was asked to describe that slope, this is exactly how I would describe that slope.